And welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is part 2 of lesson 8.5, and we're still exploring graphs and the intercept form. Okay, so this is a factored form. We know that we can use the intercept form. The intercept form, the vertex form. So we have the two intercepts here. We have the vertex here and here. We also looked a little bit about graphing using that intercept form with our line of symmetry and finding the vertex in our two x-intercepts. And we also looked at the idea of the factor x minus n, and then this, using the zero product property, we know that this is our zero, right? We solve for zero. Okay, so our first example, graphing the quadratic function using zeros, and here we have h of x is equal to x squared minus 2x minus 3. So what we want to do is find the zero. So we're going to factor this first into x minus 3 and x plus 1. So we know that x equals 3 and x equals negative 1. So those are our zeros. All right, so those are our x-intercepts, or our zeros. We also know that this point is our y-intercept. That's negative 3. And then I can also use this point over here since it's symmetrical. This is going to be our axis of symmetry here, right? You can see it's our axis of symmetry. So to find our vertex, I'm going to essentially just plug this back into the original equation. So 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3. 1 minus 2. 1 minus 2 is negative 1. Minus 3 is negative 4. So my vertex is here at 1, negative 4. And those are my points that I'm going to use to graph my parabola. Excuse my bad graphing on this device, but heck, I do what I can do. At least I'm going to fix this one over here for us. Something like that. Okay, so find our x-intercepts. Boom, boom. Find our y-intercept. Boom. That should give us a symmetrical point over there. Boom, 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 boom. And then find our vertex, right? Using our axis of symmetry. Okay, so that's graphing using those points. Now we want to write a quadratic function, and it has these conditions. The vertex is negative 3, 4, and it passes through these points here. Now I want to point out that these points, this is an x-intercept because y is 0. This is an x-intercept because y is 0. So, and we're given a vertex here. So because we know the vertex, I'm going to use the vertex form first of all. So I'm going to say f of x is equal to, I'll put the vertex form down here, is equal to a times x minus h quantity squared plus k. So a is 1. Then I'm going to say x, this is my vertex here, x plus 3, because it's minus negative 3, so x plus 3 squared plus 4. And I know that x plus 3 is going to be x squared plus 6x plus 9, using my special product shortcut, and the plus 4. And then, so this simplifies to x squared plus 6x plus 13. Okay, so let's take a look at using the intercept form here. So f of x is going to equal a times x minus p times the quantity x minus q. All right. So in this case, a and then x minus p would be minus -9, so x plus 9. X minus q, x minus -2 would be x plus 2. So in order to find a, I'm going to use the other point here, this -4 and 20, and substitute it in over here to find a. So f of x, we say is 20. That's our y value, is equal to a. And this is -4 plus 9 times -4 plus 2. So 20 equals a. -4 plus 9 is 5. -4 plus 2 is -2. So 20 equals a times -10. So a equals -2. So then I'm going to use this to write this function. So f of x is equal to -2 times, I'm going back up to here now, x plus 9 times x plus 2. Now that we know what a is, x plus 2 times x plus 9 times x plus 2 would be x squared plus 11x plus 18, and then -2 x squared minus 22x minus 36. Okay, so there we have our two different functions, one for that vertex and the one for those points. Now, of course, many different functions are going to pass through this vertex, so that's why we just used one over here just to make it easier. If I made this 2, then I'd get like 2x squared plus 12x plus 22. It would be 18 plus 4 is 22 here. So many different functions are going to use the same vertex. Okay, and then we have this set of conditions over here. Okay, so that's that. We have two separate functions there. It was a and b using the two different forms. Let's take a look at graphing a cubic function using zeros. So we're going to use zeros to graph x cubed minus 4x. Well, if I'm going to use zeros, that means I'm going to have to factor. And I know that the first thing I'm going to look for is a common factor, so x. That leaves x squared minus 4, which is a difference of two squares. So x plus 2 times x minus 2. Okay, if I set it equal to 0, then x will equal 0, x will equal -2, and x will equal 2. So that's the first, those are the points I'm going to plot. So 0, -2, and 2. So now we have to determine it's going to go this way or this way. And so what we're going to do next is I'm going to find points here at -1 and 1. So f of -1 equals -1 cubed minus 4 times -1. Okay, this is a separate thing here, right? So -1 cubed is, indeed, it's -1. And -4 times -1 is +4. So this is -1 plus 4 is 3. So I have -1, 3. -1, 3. And then I'll find another point on the other side over here. It should be here, I'm imagining, but let's just try it. F of 1 equals 1 cubed minus 4 times 1. 1 cubed is 1. 4 times 1 is 4. So 1 minus 4 is -3. So that gives us 1, 3. So 1 -3, sorry. 1 -3. 1 -3, here we go. So this will look something like this. Again, this is just kind of a sketch. And you want to make it kind of curvy looking. You want to make it kind of curvy looking. I have a hard time doing it with this equipment that I use. Do this. My lines are kind of straight, especially in here. It's kind of straight. It should kind of curve, right? More like an S through there. Okay, so that's graphing this cubic function using those zeros. And then the last one, we want to write a cubic function. This graph represents a cubic function. We want to write the function. So I can see I've got x-intercepts here of 0, 2, and 5. And I want to use the intercept form to write a function. So it's going to be similar to the intercept form that we used before for quadratics. And this is what it's going to look like. X minus P, X minus Q, and X minus R. Okay, so we added another factor, right? Because we've got 3 different solutions here, 3 zeros. Okay, so A times X minus 0. I guess go in order. X minus 2 and X minus 5. And let's see. X minus 0 is just X. And then I'm going to use the other point, 312 here, to find the value of A. So this, let's do some substitutions. I'm going to say that this whole thing is equal to 12. And that's equal to A times, what's my X? 3, right? We're using this point here. 3 times 3 minus 2 times 3 minus 5. 12 is equal to A times 3 times 1 times negative 2. 12 is equal to A times negative 6. So A is equal to negative 2. Okay, so I'm going to use that negative 2 now to write this function. And so this is going to be f of x. This is part 2 or part 3. F of x equals negative 2 times x minus 2 times x minus 5. So I'm back up here. This is kind of our function that we left off. Okay, so to multiply this together, negative 2 times x minus 2, x minus 5, that's going to be x squared minus 10x, x10, x squared minus 7x plus 10. And then if I multiply by negative 2x, I'll have negative 2x cubed plus 14x squared minus 20x. That's it. This is our cubic function. Whew, kind of involved on these last couple, huh? Well, you will be happy to know that that's it. Part 2, we're done in a snap, if you consider a snap, 14 minutes and 15 seconds. Thanks a lot. Have a great and terrific day. Bye-bye.